We are doing definite integrals or antiderivatives. Yesterday we did indefinite integrals. Today we're doing definite integrals. The only difference between those two things is it's being defined. Okay? Definite means it's being defined because we're going to have bounds involved. Okay? There's going to be numbers on our integral sign. That's going to cause us to do something a little bit different. We have done this already. Okay? You have already done definite integrals. Just so far we've only done them with graphs. Okay? For example, yesterday, I'm going to write some stuff over here to the side. You can write it if you want. You don't have to. I would say probably you don't need to. Yesterday in bell work, we did a problem like this, where I asked you to find the area under the curve from 0 to 7 of f of x dx. I think yesterday we got 6 for our bell work question. What if I would have asked you to do this and go 7 to 0 f of x dx? Why? Why did it become negative 6? We were finding the area under the curve, but we were going backwards. Here on the left side here, these are 5 topics that you need to be good at with integrals. Okay? I was looking for a bell work question today, so I was looking through a lot of old AP exams, and these 5 concepts kept happening over and over again. To apply them is really easy, but you need to be good at them. This right here is this first one. Okay? If you go from b to a of a function, if you instead found the area under the curve starting at a and going to b, or in other words, if you flip your bounds, you're going to have a negative sign. Okay, it's just the negative answer. Yesterday we got 6. If you would have flipped the bounds, it would have been negative 6. If you flip your bounds, you change the sign. Good on the first one? Number 2, we are finding the area under the curve. If I asked you to find the area under the curve starting at 2 and going until 2, you find all of the area underneath the curve starting at 2 and going to 2. How much area is going to be under the curve? 0. If your bounds are the same, you didn't go anywhere. So there's not going to be any area under the curve, so it's just 0. Number 3, this is a big thing that's going to just make your life easier when you apply this rule. Okay? Finding the area under the curve. If you just have a constant being multiplied in with your function, okay, finding the area under the curve this way, or pull constant out front is going to make the problem a lot easier to solve a lot of the time. So if you just have a constant in there, just like we did with derivatives, you can always take constants and pull them out. It's going to make your life easier. Number 4 is just kind of a common sense one. If you take 2 things and you add them together inside the integral, you can split them into 2 separate integrals. I don't need to talk about that much. A lot of these will be kind of common sense here in a second. Okay, I'm explaining them now, but here in a second you'll be able to do all of them. And then the last one is a little bit more of common sense as well. All right. If I were to ask you to find the area under the curve from A to B. So let me show you an example of this. Here's a graph. Here's my cool curve. Whee! Here's the area under the curve. Okay, let's call this A, let's call this B. The area under the curve is whatever that yellow thing is. Instead of going from A to B, let's use numbers because I hate using letters. Let's say I was going from 0 to 5. What happens if I would go from 0 to 2? So from 0 to 2, and then integrated from 2 to 5. The yellow area under there, that's going from 0 to 5. Would it be any different if I then took this area plus that area and added them together? Same answer. You can connect your bounds and make it connect to the same thing. Make sense with those 5 ideas? I hate going through examples like that. Let's put them into action. Okay, so for example, looking at letter A, we've got 3 bits of information. They like this problem on multiple choice. They gave you 3 bits of information. They said from -1 to 1, f of x is 5. They said from 1 to 4, it's -2. And from -1 to 1 of h of x, that's 7. We got those 3 bits of information. We're going to use them down below. Looking at letter A, we are trying to find the area under the curve starting at 4 and going to 1. Which one of those bits of information do we want here? Do we want yellow, blue, or purple? Blue. Why? Because the bounds make sense. Okay? So the blue one up here, it tells me, well, I'm going from 1 to 4, f of x dx. But that's not exactly what I want. Show me with your fingers, what is the answer to that one going to be? Why is it a positive 2? What do we have to do? I flip the bound. So if I flip the bounds, then I'm going to flip the sign, throw a negative in front. This is negative 2, but it's negative, negative 2. The answer is 2. Make sense? Try B. Talk with your neighbor. Figure that one out. Here we go. We are trying to go f of x from negative 1 to 4. Which one of these bits of information up here do I need to use to go from negative 1 to 4? Yellow and purple. Yellow and blue. Yeah, yellow and blue. Be careful with your letters here. Yellow and blue. So I'm using the yellow one. The yellow one is telling me from negative 1 to 1. F of x dx. That gets me to 1, but I'm trying to get all the way to 4. So instead, I'm going to add to that the integral from 1 to 4. And so by doing that, I'm still using the same starting value and the same ending value. I just have to add 2 of them together. And so I set this up. F of x dx. This guy is 5. This guy is negative 2. 5 plus negative 2 is 3. We still started with the same number and ended with the same number. We just had to put 2 of them together. Try C. Use your neighbor. Get an answer. All right. We are finding the area under the curve starting at negative 1 to 1. And we're doing F plus H. So I don't have anything up above that's F plus H. But I've got this one right here that tells me about F. And this one right here that tells me about H. So those are the 2 I'm going to use. The first one goes from negative 1 to 1 of f of x, which is great. I've got that right here. But I've got this 2. And that 2 throws me off. What can I do with that 2? Pull it out in front. So it is the same thing as this. So it is the same thing as 2 times 5. Plus this other one. Well, this one's an h of x problem, which is fine. But it said 3h of x. So again, I'm going to take that 3, pull it in front. So it's 3 times that value, which is 7. 10 plus 21 is 31. It's a lot of common sense kind of stuff. It's not as complicated as it seems. It's just a matter of applying some rules. Questions on C? Try D with your neighbor. Here's the fun when we're trying to evaluate this thing. We're evaluating f of x from 0 to 1. So looking at my choices up there, which color would make the most sense to use here? Yellow, blue, or purple? Yellow would make the most sense. Okay, it's not perfect because my bounds went from 0 to 1, but that one, the bounds went from negative 1 to 1. Everybody agree with me on that? All right, so let's think about this as a picture. So from negative 1 to 1, there's some graph, and when I find the area of the curve, it's 5. Anybody know what that curve looks like? Me neither. They didn't tell me. Okay, so I'm going to just draw what I want f of x to be. This is f of x. Look how pretty that is. See how nice and balanced that is? The area under the curve from negative 1 to 1, this right here, I told you is 5. So if that whole thing was 5, what would it be from 0 to 1? 2.5. Wouldn't that be great? Do we know what the curve looks like? No. So that's what you want to do. Don't do that. That's bad. Because you have no idea what that curve looks like. It would be great for that curve to be straight, but maybe that curve looks like this. Whee! Whee! Look at that curve. If I split that in half, is exactly half of it to the right? No, I have no idea what the area of the curve is. Maybe it looked like this, and they're not even close to half underneath. And so instead, the answer to this one is, I don't know. All right. You wouldn't want to say D and E. Okay, earlier students were telling me D and E. D and E means it doesn't exist. It exists, I just don't know what it is. So, then the next question is that what I'm going to put on the AP exam? No, because that's not how it would be asked. It would be a multiple choice question, where one answer was like 6, one answer was 10, one answer was 2.5, and then part D would be not enough information to determine the answer. That would be the one you pick. Questions on D? Let's look at letter E. Letter E. We are finding the area under the curve from 1 to 4 of f of x plus 2. I really like this question, and they ask it quite a bit. It takes a few more brain cells to understand this one. All right. Which thing up above are we going to use if we're going from 1 to 4? The blue one. We got this negative 2. Let's come back to that here in a second. let's take a side note for a second. And let's talk about what if, we'll call it g of x, just because. We'll say g of x is equal to the absolute value of x. All right, and let's integrate g of x from negative 2 to 2. All right, so imagine what this looks like. I got this picture right here. I called it f, but let's call it g instead, just that way we can be the same. This is what g of x looks like. Everybody agree? Absolute value. Our job is to find the area under the curve. No, I'm not going to be able to do this because I'd rather do this on my screen. I'll write on my whiteboard up here. So if we're finding the area under the curve, I got this part right here. That is what we're doing if we're integrating from negative 2 to 2 of g of x dx. Everybody agree with me on that? So after talking about that on the whiteboard, let's go back to this one. We're integrating from 1 to 4 f of x and then plus 2. So we learned back on this problem right here, we can split up the integrals. So I could split this up as the integral from 1 to 4 f of x dx plus the integral from 1 to 4 of 2. We know what this answer is going to be because they gave it to me. Okay, up here it said 1 to 4 f of x dx is negative 2. Talk with your neighbor. Figure out the second part. Show me an answer when you find it. Integral from 1 to 4 of 2. Here's my graph. Here's 1. Here's 4. Show me with your arm. What does 2 look like as a graph? 2 is this guy right here. So here's the line of 2. So the area under the curve starting at 1 going to 4. How wide is that rectangle? How tall is it? So what's the area under the curve? Negative 2 plus 6 is 4. You could think of it as adding a rectangle or integrating a separate rectangle. It doesn't really matter. They both get you the same answer. It's the idea of shifting my graph. That is something pretty common. I guarantee they throw one of those in your multiple choice section when you get to that AP exam. Let's flip that thing over. Let's go backside. All right, on the backside here, we are talking about the fundamental theorem of calculus. It has a pretty important sounding name. It's the fundamental, so it's the most basic theorem in calculus. That's probably disputed a little bit, but that's the idea. Okay, it has 2 parts. Okay, and the parts are so different. We learned part 1 in this chapter, and we'll learn part 2 in the next chapter. But here's what it says. Okay, the definite integral. So far we've just looked at graphs. Now we're going to look at algebraic ideas. The definite integral. So if you wanted to integrate this thing from a to b of f of x, the way you do that is you find the antiderivative. You find capital F. You plug in the lower bound and the upper bound, and you subtract those 2 answers. And by doing that, you're going to find the area under the curve. That is what the FTC states. Let's show you that graphically and then algebraically. So let's do it graphically first. So we are finding the area under the curve of 6 graphically. So let's draw a picture of that. Here's a graph. Here's 1. Here's 3. What does 6 look like as a graph? Boom. Horizontal line here at 6. I'm finding the area under the curve from 1 to 3. What's my answer going to be? 12. It's a width of 2, a height of 6, 2 times 6, the answer is 12. Boom, that's it. Just like we did on the front side, it's just a rectangle, which would be great. I wish we could do that all the time, but not every graph is as easy as just a straight line. Okay, sometimes lines will be curved, and that's why we're going to learn a different method. Okay, so let's do this same thing, but now algebraically, okay, using FTC. So here's what FTC said. We need to find the antiderivative of this thing. So the first thing I need to do is find capital F of x, or the antiderivative of 6. The antiderivative of 6 is 6, add 1 to my exponent, so it's x. Divide by my new exponent, it's still 6. And then before, we would say plus c. Okay? We said plus c when it's indefinite, because it was just a value. You don't need a plus c here. Okay, because eventually we're going to subtract the two things, and if you subtract constants, they would disappear. All right, so we don't need that, but we are going to do something else. Okay, FTC says we're going to evaluate it from 1 to 3. So we're going to draw this line. It almost looks like an absolute value line. And on the top, we're going to write our upper bound. And on the bottom, we're going to write our lower bound. It's just notation to show, hey, I need to plug in these two numbers. Okay, that's all that means. It's a straight line. You put upper bound, lower bound. So now what we're going to do is we are going to find capital F of the upper bound. And we're going to subtract from that capital F of the lower bound. Or in other words, 6 times something minus 6 times something. Upper bound is 3. Lower bound is 1. 6 times 3 is 18. Minus 6 times 1 is 1. What's 18 minus 6? 12. That is the fundamental theorem of calculus. Again, on this problem in particular, it makes sense to draw a graph. But we're going to get more complicated graphs, and that's why we're going to use FTC to solve these definite integrals. Questions to this point? Let's do it. Example 4. We're using FTC to solve the integral from 1 to 3 of 4x dx. So to do this, just like before, we're going to start off by finding the antiderivative. So if I'm finding the antiderivative of 4x, Jacoby, what would my new exponent be? Yep, add 1 to my exponent to make it 2, and then my new leading coefficient, 2. He divided by his new leading coefficient, it's 2. We took an antiderivative, so normally we would say plus c, but because it's a definite integral, the plus c won't matter because they would cancel out. Instead, I'm going to just think about my bounds. I'm going to evaluate this thing from 1 to 3. So then I'm going to find capital F of 3, and then subtract from that capital F of 1. Go ahead and do that with your neighbor. Show me your answer when you get it. We got you to the easy part here. Once we're here, it's just a matter of looking at it this way. We can plug in 3. We can plug in 1. 3 squared is 9 times 2 is 18. 1 squared is 1 times 2 is 2. 18 minus 2 is 16. A lot of times, students are going to struggle with the simplifying of this thing. There's a lot of mistakes you can make, and we'll point those out as we go, but be careful. If this were a free response question, that right there would be a wonderful answer. Leave it there. If it's multiple choice, you got to work your way down. But otherwise, leave it with just numbers. You're good. Let's go to example 5. Do it with your neighbor. Go. Here we go. We're doing 2t minus 3. We're finding area under the curve. So, to evaluate this thing, Logan, what's the antiderivative of 2t going to get me? T squared minus 3t. Good. We did an antiderivative, so normally it's plus c. But because I have bounds, the constants would cancel. I'm evaluating that thing from 0 to 2. So, you're then doing f of 2 minus f of 0. So it is something squared minus 3 times something minus something squared minus 3 times something. Let me show you a big mistake that students make. Okay, this one, it didn't matter, but other times it would. Let's say instead of going to 1 or 0, let's say I was going to 1. All right, so 2, 2, 1, 1. Would that be the correct answer? Why not? What would I need to put in here? Parentheses, because you're subtracting all of that thing. Otherwise, you would only subtract the first part when you're subtracting all of it. So a couple things you can do. Always put it in parentheses, okay? Or don't write down the minus sign until you evaluate it. Either one is fine, okay? But be careful with that. Otherwise, you will screw it up. That is the number one mistake students make. All right, so back to the actual problem. 2 squared is 4 minus 6. This is negative 2. This is 0 minus 0. That is 0. Negative 2 minus 0 is negative 2. That is my answer. A reminder that we did this in our calculator back earlier. Okay, so if you did this problem and you were like, did I get the right answer or not? And it was just checking your homework, you could always do it here. Remember we did math 9? We evaluated that thing from 0 to 2. 2t minus 3 dx, hit enter. Oh yeah, I got negative 2. Try the next one. Number 6, evaluate it all the way down. Get a fraction in the end. When you find your fraction, show me with your fingers what your denominator was. For the most part, we're doing well here. This one just gets a little bit more complicated because you've got more parts. So I'm going to start off as writing this. Sorry. This is 2/3 x squared with a negative sign because it's on bottom. Now we're finding the antiderivative. If I'm finding the antiderivative here, Evan, what's my new exponent going to be?
New exponent is going to be -2.
It was -2, so now it's going to be
Oh, my bad.
-1. He added 1 to his exponent to get -1, and then he's going to divide by the new exponent. So far, I've seen 3 classes today. Everybody has made that mistake that they divided by the old exponent, not the new one. So if I'm dividing by -1, what's my new coefficient going to be? -2/3. That's what f of x is. Normally, it would be plus c, but I've got bounds, so I'm evaluating this thing from 5 to 10. Okay, let me show you a trick here that might make life a little bit easier. So we're doing capital F of 10 minus capital F of 5. So we are doing -2/3 times 10 to the -1 minus -2/3 times 5 to the -1. You can write it like this. It's totally fine. But do you notice anything that both parts have in common? -2/3. There's a constant of -2/3. So you can write it just the way we did, or, which will happen quite a bit, especially with multiple choice answers, we could factor a -2/3 out and just be left with this part. So in other words, it's just 10 to the -1 minus 5 to the -1. Same thing. We just factored it to make our life easier. Then we're just working from here. So -2/3. -1 power is going to do what to it? 1 over 10 minus 1 over 5. Just flipped it. We can get some good old common denominators. So it's 1/10 minus 2/10. -2/3 minus 1/10. Or times -1/10. So in the end, is my answer going to be positive or negative? Positive. It's 2 over 30, or in other words, 1/15 was the answer I wanted there. Factoring out a constant, if they have one, can make your life easier if it's messing with it. I made a mistake as I wrote this problem. Notice that I go from x to dt. It would either be t and t for both of them or x for both of them. I just made a mistake. X to 1/2 dx. We're going to find the antiderivative. That's how we're starting off here. Jason, what's my antiderivative? What's my new exponent going to be? 3/2, and what do you need to do? So what's it going to be? 2/3 x to the 3/2. We're evaluating that thing from 1 to 9. So if I'm evaluating that thing from 1 to 9, it's f of 9 minus f of 1. Are there any constants here in that setup? 2/3 is a constant, so if you would like to, which I would suggest, take that 2/3 and pull it out in front. So then all I have left is 9 to the 3/2 minus 1 to the 3/2. If this were a free response question, box that up and call it a day. If it's multiple choice, we got to simplify, and I'm going to warn you that these are normally multiple choice questions. 9 to the 3/2. That is a one skill that we really struggle with. You got to be able to do it. Again, that's Algebra 1, Algebra 2. 9 to the 3/2 power. Okay, start with the bottom number, the 2. What's that 2 mean for our 9? Square root. Square root of 9 is 3. And then I'm going to take 3 and cube it, so I'm going to get 27. Minus 1 to the 3/2. Well, 1 to any power is still going to be 1. 27 minus 1 is 26. Times 2/3, so 2 times 26 is 52 all over 3. Questions on what we added today?